Assalamu alaikum, good morning, good evening, bonjour, bonsoir, folks. Hopefully you'll all be fine, depending upon when you are watching the video. So greetings to all. I'm ABDUL BASIT, and today we'll be dealing and I'll be telling you about the smart sensor simulation with the integrated circuit of the different integrations. So hopefully you'll enjoy the video. Let's get started.
Okay guys, so this is our main simulation of the smart sensor. You can see that this sensor is actually this simulation is entirely composed of many small integrated circuits. You can see that there is an Arduino Mega. You can also see there is a voltage sensor, there is current sensor, there is a motor which is encoder based. Then you can see there is an XOR gate which is attached with the counter. You can also see that there is a monitor, and on the extreme left side you can see that there is an SD card and the RTC for the data logging, and you can see there's LEDs over here. So before going to the main simulation, I must want to show you some of the pictures of the main of the small integrated circuits that comprises this whole simulation, because there is many small components just like relay, ULN, and diodes and electromechanical switches. So let me show you first how this whole circuit is comprises and on which component it is. So this is, you can see, this is an Arduino Mega. It's a microcontroller which is based on 80 Mega 2560. It's an 54 input microcontroller in which you can see that there is an different pin configurations, and there is the deviance according to the power inputs and the outputs. So this is an Arduino Mega. Then for further proceeding, if this is the main, you can say, the source code on the initial basis regarding the processor of which is Arduino Mega we are using over here. And this is just the starting the setup, word setup. This is for the initialization of your the things, you functions you want, and then this loop in this area you just plug in the main you can say the body of the code. So this is the first integrated circuit which you can see this area. So first we'll be dealing with this region, which is an Arduino Mega, and which is attached with we have attached a proximity switch. This is a push button, and let me show you. This is the first the basis of how we had developed this whole entire simulation. So before proceeding towards that one, we'll consider this one. So you can see that there's a push button, and we have attached an optical isolator with that, so that if there is any voltage which is more than 5 volt, this will make ensure that it will isolate the more voltage which exceeds the value of 5 volts. So this is you can see that this pin, this is we have used you can see that in our whole simulation, in our whole patching of the circuit, we have used netting instead of joining them with the wire, so that to just make them a neat circuit instead of making it bit congested and regardless of bit messy. So we had just used netting, and you can see that this, let me zoom this first. You can see that this IO2 pin is connected with this IO2, this one, and इट्स द सेम, बाकी सारी भी जो हैं वो इसके साथ जो हैं पिन्स के साथ अटैच्ड हैं. सो दिस इज़ द आउटपुट ऑफ द सर्किट, दिस इज़ द LED, and when we push this button, when we push this LED just starts to glow on, and it's a simple configuration that we have added in the source code too, and let me show you that too. You can see that there's a button state. It's as it is a smart sensor, so we have to make sure that we will be introducing some microcontroller with the inputs that will be considered as an output. So based on that, you can see that we have just developed a simple logic, which is that when as the button will be pressed, where there will be a high state in the output, and when button will not be pressed, there will be a low state in the output. So this is the main simulation. You can see that there's a button, there's a push button. Whenever I'm just going to press it, this simulation will start to work, and this LED will glow on later on. I'm gonna show you. So this is the changes we have made in the code. Before that, it was just a simple one. So when we had add some integrated some circuit with which is a simple push button with the output in the LED, and then for this circuit we have you can say just integrated for optical isolation. So this is the VCC, which is it will be just like constant, and we can increase or decrease this one. So for introducing this, we have made some changes in the code. You can see that. Then we have you can see that if we'll start to divide this and this circuit, this push button, and if we'll consider this output region, we can also integrate many few circuits. जिसमें आप देख सकते हैं कि इसी को हम अगर mirror कर लें, we will consider this region and then this LED. So and उसके साथ हम इसमें IO2 IO0 जो हम इसके साथ इसकी पिन कॉन्फ़िगरेशन हम यूज़ करें, हम इसी तरह सर्किट को enlarge करके हम different circuits develop कर सकते हैं. So next come if you'll see that I was talking about a relay, and then I was talking about the electromechanical switch. So this is the thing which is attached with the ULN. So let me show you what I was talking about. This is a simple motor which is attached with the you can say we can either attach a motor, or we can either attach whatsoever our required output device is. So this is an electromechanical switch. I hope you are familiar with that. And this is an you can say a diode, and then we have attached it with the ULN. So whensoever there will be a magnetic field created, the switch will be open and closed, and you can see that this is in an closed not in closed situation, it's in open, and whensoever it will just attach over with the presence of mechanical fields, electromechanical, so it will magnetic field, it will be just attracted, and the switch will on. So in that we can see that this pin is again we are using netting over here, so it's IO13 over here. So in Arduino Mega we have dash IO13 with this pin configuration of the ULN. Then going further, we can see that in this region there's let me show you, there's a motor in which there are 3 pin inputs outputs in fact, which are the pin configurations. So talking about that, we have just attached an oscilloscope to analyze the signal behavior of the motor, which is changing with the current and voltages with the time they are varying. So to you can say to demonstrate that, to show that, we have attached an oscilloscope, and let me show you. This was the next part in the picture. So you can see I'll also show you in the simulations, and when we are going to run that simulation. So you can see that we will be getting A, B, C of the just like this A, B, and C. We will get this, some signals which will be showing us that about the various graphic and analysis. So this is a motor which is you can say which is inbuilt with an encoder. So we don't require an encoder in this form. Also you can see there's an XOR gate, and when we are attached this with the clock. So the purpose of this is to measure the frequency of the motor. Then further proceeding, if I'll say, we have so this is the circuit that first we have started with this. First we have started just with the simple Arduino Mega. Then we have integrated it with a switch, proximity switch with a push button and LED as an output. Then we have developed an electromechanical switch with an motor which is a DC motor, which in working as an actuator. You can we have clearly an idea about that. Then we have attach an counter which will within an XOR gate as an input, so that it will be measuring the frequency. Then further proceeding, we have introduced an voltage sensor to measure the voltage of the motor varying with the time. So this voltage sensor you can see is over here, also in the main simulation, that there is an resistor, there's an linear diode, there's a capacitor just for making sure of the stability of the smoothness of the current. Then we have attached these two. This is also for the calibration of the voltage. So this is the voltage sense node. Here will be measuring it, and there are also resistor to make sure that there is no exceeding of the voltages and the currents also. So basically when we are going to simulate it, we'll be having some particular voltage over this due to the motor. So this is a voltage sensor, and voltage sensor is mainly it's an input tolerance of 5 volts. So 5 volt से exceed ना हो तो उस चीज़ को avoid करने के लिए we have to use this. So again you can see there's a netting, and we have used you can say, let me zoom this. We have a ADO, you can see we'll be using as in pin configuration for that. So this is again for the neatness of our circuit, to avoid that. So you can see that there's an ADO 0 where we had integrated it with attached the pin configuration with via netting into the Mega Arduino. So coming back, this is again for measuring the voltage of the motor. Then if we'll come next, if we'll proceed to the next picture, I must show you. So let me just plug it. So basically we have started it with the simple configurations, and then we have made it in large. So let me show you the main simulation. It's you can see that there is also a current sensor, which is again is used for measuring the current of the motor. So it's you can say it's a 5 volt AC or DC. It works, you know, both on AC and DC. 5 volt same, and analog voltage as an output it gives. Then you can see that you can also see that there's a SD card, and there's an RTC real-time configuration will be showing. It will be shown by it. So it's a real-time counter. So what's the purpose of that? Whenever we are running the the main simulation, so we'll be getting whatsoever result, it will be stored over here. And अगर आपकी कोई values वगैरह miss भी हो रही हैं रात, for example आपने अपनी simulation run की हुई है, so it will make sure that wherever the circuit breaker collapse, it will just keep the data stored. So in the you can see that this SD card, this can be plugged in and plugged out. It can be via these switches, and this is an RTC. So it will be आप इसकी अगर configurations में जाके यहाँ पे and आप इसकी edit file करके, so you can edit properties, and you can open this file into this is the file, and you can open this into the notepad, and then you can get the readings whatsoever it is storing. It will be storing. Let me just simulate this first, and you can see that once it will just start, it is just started. So it is giving the values of the current and the voltage and the battery and the time. And also you can see this is the simulation was graphical, you can say representation by CRO of this motor. So you can see that this motor is functioning, right? This is working. So इसकी frequency साथ साथ हमें बताता रहेगा this counter, just like it's going 5, and this so this is the in counter clock we have used for with an XOR gate. Also you can see that हमारे पास बैटरी की voltage आ रही है, मोटर की जो हमारे पास voltage है, then current आ रहा है हमारे पास, and इसके साथ साथ अब ये जो values होंगी ना, ये values हमारे पास इस SD card का purpose है. This SD card will be storing that those values, and also it will be recording the previous data और वो उसको override साथ साथ accordingly करता रहेगा. So you can see if I'll be showing the LED which I was talking about. So अब ये switch हम इसको manually भी open and close कर सकते हैं, but generically क्योंकि इस simulation के साथ इसने भी run होना था, we have made some changes in the code. So अब ये हमारे पास push button, for example, you can say that ये अपनी close state में है, and then we can see that there is an LED. This SD card is storing, purpose of this is storing the values of these current and voltages. This again, this voltage sensor and current sensor is sensing and recording the values of this. We can also increase and decrease the values of the voltage and sensor once we are going to do that. So the motor, you can say, if I'll be showing you, so let me just do it. If I'll be increasing the value, so once it will exceed the 5 volts, so the motor will just stop, and it will be, for example, I've done this, so the motor will stop eventually. You can see that we have changed the frequency, and if I'll be lowering it, so then again it will be having an effect. So you can see that it's decreasing, and when we have increased it, just you can see it also increased. So अब हमने इनकी बिल्कुल zero कर दिया, so it's just like, you know, you can see the effect of the current and the temperature. So हम इसको vary करेंगे तो साथ साथ ये भी हम इसको vary कर रहे हैं मोटर की. You can see that there is a sudden drop of 10 frequency hertz. It was 13 when I was increasing it. So this is the basic, you can say, configuration. We can adjust the values. These are the also for the calibration, same is for the voltage and the current sensor. And अब हम इसमें और क्या कर सकते हैं, हम इसमें वी कैन ऑल्सो स्टडी कि हमने कितने वोल्ट सेंसर की मतलब हमारे पास उनकी टॉलरेंस क्या होगी, हम अपना कितने GB का SD कार्ड यूज़ कर सकते हैं, एंड रिक्वायर्ड फर्दर. सो दिस इज़ एन मॉनिटर. So I hope you guys are familiar, and I'm clear to you कि अगर आपको कोई मसला ना हो. So this is basic smart sensor integration, and this is the glow. You can say this is the main process of the you can integrate any smart sensor. So coming back to the mechatronics, you can see that आप किसी भी circuit के अंदर अगर आप micro controller आप एक simple circuit में attach कर लेते हो, so you can convert into this smart sensor. So this is a basic demonstration and example of that. You can see that everything is just running smoothly and it's giving the readings. So this is the purpose. Coming back on the, if I'll say, to the simulation, this is the source code. If I'll be showing you that these are functioning. This is the PCB layout. Let me show you the source code first. It's actually, I hope, okay. So this is the source code. You can add the various changes to it. Once you are adding the components, you have to make the changes. So you can see that this is the netting. We have when we are getting voltage, so we are getting voltage at 8 or 0 and A2 पे current हम कह रहे हैं हमें चाहिए. So this is the main functioning we are using. Then this comes the button जो हमने यूज़ किया है, push button, and उसके साथ LED pin के साथ जो हमने उसकी configuration है. So this is you can see it's main source code which is added to it, and we're using different functions. So for this you can say, तो आपने इसको सबसे पहले जो आप साथ करते जा रहे हैं साथ साथ आप उसका कोड ऐड करते जाएंगे, and this will give you a simple main simulation of this circuit. So thank you so much. Now we'll proceed to our next simulation, which is of a proposed sensor. Thank you. Okay, so this is one of my proposed sensor, which is actually the vibration sensor module based on the vibration sensor SW420, and the comparator which is LM393, and it is used to detect vibrations. The threshold can be controlled by using this potentiometer. It's a variable potentiometer, so variable resistor, we can just turn the dial to the clockwise and anti-clockwise to vary the threshold. So actually during no vibration, the sensor provides the low logic, and the LED which is just shown over here is just turned off. And during when the vibration is you can say sensed, it is detected, and sensor provide high logic. So this is actually let me just open up its image, and this is actually the picture of SW420, which is the vibration sensor. This is it's actually the vibration sensor. Then comes the comparator, which is LM393. This is the comparator IC. Then there comes the potentiometer, and there comes the LED. So this is the groove vibration sensor SW420. We can take a look from the data sheet that it is a very high sensitivity non-directional vibration sensor. When the module is stable, when it is in the stable state, the circuit is turned on and the output is high. When the movement or the vibration occurs, ये आप अपनी logic different create कर सकते हैं when the डिफरेंट डिमांड्स के आप किस तरह करें. फॉर एग्जांपल जिस तरह यहाँ पे मैंने रखा हुआ है इन आर सोर्स कोड, यू कैन सी कि इफ़ हमारे पास हाई वैल्यू होगी, इफ इट इज़ हाई, सो हमारे पास जो आउटपुट होगी वो हाई होगी, एंड व्हेन इट इज़ एलईडी को टर्न ऑन कर देना. एंड जब हमारे पास अगर नहीं है हाई, सो हमारे पास एलईडी ऑफ रहेगी. और ये हमारे पास एक सिंपल सा सोर्स कोड है इसका. सो ये आप देख सकते हैं, और इसका ये पीसीबी डिज़ाइन है और ये स्कीमेटिक है. सो कमिंग बैक ऑन द डाटा शीट, इट्स द सेम जस्ट लाइक जब हमारे पास एक स्टेबल मूवमेंट है, when the module is stable, the circuit is turned on, means it is on the high state, and LED will glow. And when the movement, or when there is a movement or vibration occurs, the circuit will be disconnected and there will be output low, and there will be no light turned on. So its feature includes that it's non-directional, high sensitivity, respond to vibration, tilt. अगर आप में किसी भी जिस डिवाइस के अंदर यूज़ कर रहे हैं उसको अगर आप टिल्ट करते हैं किसी सर्टेन एंगल के ऊपर, तब भी ये आपको सेंसिटिविटी उसकी इतनी होगी कि वो उसको डिटेक्ट कर रहा होगा. वाटरप्रूफ है एंड कंप्रेशन रेजिस्टेंस. सो इट्स ऑपरेटिंग वोल्टेज इट्स अबाउट 3.3 वोल्ट्स टू 5 वोल्ट, एंड इंटरफेरेंस इसका जो है वो डिजिटल है. एप्लीकेशंस हमारे पास वाइब्रेशन सेंसर्स में बहुत सारी हैं, जैसे कार, बाइसाइकल्स एंड बर्गर्स, आर्म्स, गेम कंट्रोल, वाइब्रेशन डिटेक्शन. सो दिस इज़ एक्चुअली इट्स पिन कॉन्फ़िगरेशन विच इज़ यू कैन सी दैट द आउटपुट वन जो ये हमारे पास फर्स्ट पिन है, ये हमारे पास आउटपुट के लिए है. थर्ड जो है हमारे पास VCC, जिस पे आप वोल्टेज अप्लाई कर रहे होगे, जो कि आइदर 5 वोल्ट्स होगी या 3.3 वोल्ट्स के वेरी कर रही होगी. एंड दिस कम्स द ग्राउंड, ये हमारे पास ग्राउंड है. and then this is the potentiometer, and the potentiometer this 6 pin is the ground pin of the potentiometer, and then this is the this is actually SW420 vibration sensor, and you can see there comes a LED. So coming back, this is the schematic diagram in which we can see that of the circuit, in which we can see that the first if we will be starting from SW1, which is at lower left corner. Actually SW1 is the let me just wait, and okay, so let's begin with SW1, which is this it is on the left corner. Actually SW1 is the vibration module जो कि हमारे पास SW420 है. जब हमारे पास ये स्टेबल स्टेट में होता है तो ये इसमें हमारे पास हाई आउटपुट होता है, जब स्टेबल स्टेट में नहीं होता है तो हमारे पास लो आउटपुट होता है. तो इसकी जो पिन 2 जो है हमारे पास वो हमारे साथ ग्राउंडेड हुई है विद द पिन कॉन्फ़िगरेशन ऑफ 1. देन कम्स द VR1, दिस इज़ द VR1 एंड दिस इज़ द पोटेंशियोमीटर. इसकी जो पिन 2 है वो हमारे साथ कनेक्टेड है. यू कैन see it's connected with the pin 3 of UA1. This is the UA1. So this is then comes the LED, and then comes the comparator. So इसकी this is the हमारे पास एक लॉजिक है कि हमारे पास पोटेंशियोमीटर वोल्ट्स हमारी उसकी वोल्टेज अब हाई होगी तो कंपैरेटिव जो लो हो रही होगी तो अब हमारे पास एक हाई वोल्टेज प्रोड्यूस हो रहा होगा। और ये हम लॉजिक अपनी चेंज भी कर सकते हैं डिपेंडिंग अपॉन कि हमें किस तरह उसको ऑपरेट करवाना हो चेंज करके, लेकिन उसको लॉजिक भी आपने साथ साथ चेंज करनी होगी। सो इफ़ दिस मॉड्यूल इज़ इन अ स्टेबल स्टेट एट W1 जो है हमारे पास टर्न ऑन होगा, और जो पिन 2 ऑफ UA1 है इज कनेक्टेड टू द ग्राउंड थ्रू द S1 विल बी द स्टेट। एंड अगर हमारे पास कोई भी वाइब्रेशन आती है तो हमारे पास दिस स्टेट विल कम फॉरवर्ड एंड देयर विल बी अ लो आउटपुट्स इन द produced by the vibration sensor, and there will be the no turning on of the light. So this you can see that this sensor is mainly composed of it's actually made up of you can say it's there comes the potentiometer, and then there comes the LED, and then there comes the comparator. So it's actually the main feature of that. It is comprises of some little components, and I'll be giving you a brief description of that. Just like it comprises of a resistor, capacitor, potentiometer, comparator, and IC, and then power, and then status LED. LED जो है इज़ वेरी यूजफुल, जिस तरह जो हमारे पास जब आउटपुट शो करेगा, सो whenever there will be triggering or some vibration, so LED will be showing us. So LM जो हमारे पास 393 जो कि हम बेसिकली यूज़ करें एज एन आर कैपेसिटर, मतलब कंपैरेटर IC जो है हमारे पास, ये हमारे पास एज एन वोल्टेज कंपैरेटर यूज़ करें इन दिस वाइब्रेशन सेंसर। इसकी जो पिन 2 है वो LM 393 की इज़ कनेक्टेड टू प्रेजेंट हमारे पास प्रीसेट के साथ कनेक्टेड होती है, एंड वाइल पिन 3 जो है वो हमारे पास वाइब्रेशन सेंसर के साथ कनेक्टेड होती है। तो और इससे जो है ना क्या इसका क्या फीचर है, द कंपैरेटर IC विल कंपेयर द थ्रेशोल्ड वोल्टेज सेट यूजिंग द प्रीसेट एंड द वोल्टेज वाइब्रेशन सेंसर ऑफ द पिन 3 जिसके साथ ये कनेक्टेड होता है। देन कम द SW420, अगर मैं इसके बारे में बात करूँ, सो इट इज़ द वाइब्रेशन स्विच विच रिकॉग्नाइजेज द एम्पलीट्यूड ऑफ द वाइब्रेशन टू विच इट इज़ exposed. The switch response can be electrical contact, और या फिर हमारे पास किसी ओपनिंग और क्लोजिंग के साथ होता है। The electrical contact may be either electromechanical relay or a solid state device। ठीक हो गया। So हम इसको अगर वाइब्रेशन में अगर मैं कहूँ टोटल ऑल इसकी फंक्शनिंग क्या है, सो वाइब्रेशन सेंसर मॉड्यूल कंसिस्ट ऑफ, मतलब इट कंसिस्ट ऑफ 3 पिन्स। अगर हम अपने इस सिमुलेशन के ऊपर वापस आएँ, let me just open this up. So it consists of 3 pins. You can see one is the VCC, another is the ground, and then the third one is the digital output. So the digital output is connected to the output pin of the LM393 कंपैरेटर IC के साथ ये कनेक्ट होता है। द इंटरनेट सर्किट डायग्राम और जो हमारे पास है वो मैंने आपको स्कीमेटिक में दिखा दी थी। सो इफ़ आई जस्ट रन दिस, सो यू कैन से जब हमारे पास एक हाई स्टेट होता है तो ऑन हो जाती है, और जब एक स्टेबल स्टेट होता है तो ये हमारे पास ऑफ, मतलब दिस इज़ द ऑफ स्टेट है। और वैसे जब हमारे पास दिस इज़ अ स्टेबल स्टेट, ओके। सो जब कोई भी वाइब्रेशन होती है तो ये हमारे पास टर्न ऑफ हो जाती है light, and this gives us vibration sensor. So इसके then it comes मैंने आपको सोर्स कोड दिखा दिया है, एंड इसका ये PC भी वर्जन है। सो इसके काफ़ी एप्लीकेशंस हैं, जिस तरह ये शॉक ट्रिगलिंग के अंदर यूज़ होता है, बर्गर आर्म्स के अंदर, स्मार्ट कार्ड्स के अंदर यूज़ हो रहे हैं, जिस तरह उनके अंदर कीलेस एंट्री के अंदर जो हम सिक्योरिटी सिस्टम लगा रहे होते हैं, तो कोई वाइब्रेशन होती है तो डिटेक्ट करता है, एंड देन इट साउंड्स। So this is basically a small simulation and working and explanation of vibration sensing. So I guess it is enough. Thank you.
Hope you had all enjoyed the video, so don't forget to comment on the comment section if you do have any queries, and do like it, subscribe it. Thank you so much. Take care of yourself. Happy quarantine. Stay blessed.